Hello everybody, this is Danny Mathematics 3.0 and today I'm going to go over example 1 of how to solve systems of equations by the elimination process. Once again, we're going to be solving systems of equations by elimination, and we have this first example. So this example right here, guys, this is an example of a system of equations, right? Where we have multiple equations that fit a system, okay? And our mission is to figure out the values of X, Y, and Z that makes this system true, all right? That makes this system true. That's what we're trying to do. We're trying to find out what is the value of X, what is the value of Y, and what is the value of Z in this one that will make this equal -4, and the same thing with these other two equations, okay? So what we want to do is, the first thing that we need to do is we need to label. We need to label. So the first thing we're going to do is we're going to label each equation that is in the system. So I'm going to label this one as equation 1. Actually, let me get a better one. Let's see if this is better. Okay, this is a little bit better. I'm going to label this equation 1. I'm going to label this equation 2. And I'm going to label this equation number 3. Okay? So step 1, and I have all my steps because this is a long process, okay? So step 1 is, the first thing we want to do is we want to figure out which variable do we want to eliminate first. Either we can pick X, we can pick Y to eliminate, or we can pick Z. I've already did this before, so what I'm going to do is I'm going to follow the steps that I've already done. In step 1, we're going to eliminate X, okay? So step 1. Okay, because we have to eliminate 2 values to find out 1 value, and then the 1 value that we find out, we can find the other 2 values, okay? So we're going to eliminate X. And we're only going to take 2 of the 3 equations. So the 2 that I'm going to pick, it could be any 2, but I'm going to pick 2 and number 3. So we're going to use equation 2 and equation 3 to eliminate X, okay? So I'm going to go ahead and write equation 2, which is this equation right there, which is the middle one. I label it as 2, so I'm just going to rewrite it. So I have -2x minus 2y plus z equals 4, okay? And then my third equation, I just have -x plus z equals 5, okay? And what I'm gonna do is I'm gonna always color code the variable, so it will be easy for you to follow along as you're watching this video. I'll put a z and a z, okay? So we wanna eliminate X, right? Now, in the first one, it's -2x, and this one is -1x, right? Now, what we can do is we could take the second equation, which is actually equation number 3. So we can take equation number 3, in order to eliminate X, we can times it by -2, because if we times it by -2, this X right here is going to become positive 2x rather, right? And a -2x and a positive 2x eliminates, okay? So that's what we're going to do. So let's go ahead and do that. So once again, I'm going to multiply this one by -2, okay? So once again, I'm just going to bring everything down. I still have equation 2. It stays the same, which is -2x minus 2y plus z equals 4, okay? And once again, I will always label each equation so it's easy for you to follow along. Okay, but the third equation, right, which is this one, I'm going to multiply it by -2. I'm going to multiply it by -2. So a -2 times a -x equals a positive 2x. Okay, there's nothing for y, so it's nothing. And z times -2 is a -2z. And 5 times -2 is a -10. So far we have manipulated the third one, and we have made it to be 2x minus 2z equals negative 10, okay? So as you can see, guys, a negative 2x and a positive 2x cancels, okay? So all we're gonna do is we're just gonna add everything and we're just gonna put everything else together, okay? So I'm just gonna bring that negative 2y down. Z plus negative 2z is a negative z. And 4 plus a negative 10 is a negative 6. So we actually created a new equation, okay? And we're gonna label this equation, we label these as numbers, so I'm gonna label this as a letter equation, okay? I'm gonna label it as a letter. So I'm gonna label it letter A. So remember, we created a new equation, which is equation A, okay? So now, what we need to do is we need to use another 2 equations to eliminate x once again, okay? So we're gonna eliminate x once again. So let's do step 2, which is eliminate x again. Okay, and in this particular step, I'm going to use equation 1 and 3 to eliminate x, okay? So I'm going to use, and then once again, it doesn't matter which 2 that you use, okay? You just have to pick 2. So I'm going to use 1 and 3 to eliminate x. So I'm about to rewrite number 1, which is this one up here, which is negative 5x minus 3y plus z equals negative 4. Once again, I'm going to color code everything so it'll be easy for you to follow. Okay, and then I'm going to rewrite number 3, which is this one, right? Which is just a negative x, there's no y, plus z equals 5. Color code everything, and once again, we are going to eliminate x, okay? Now, if you notice, guys, in the first one, and I'm sorry, I need to label this as number 3. So in the first one, in the first equation, I have a negative 5x. In the second one, I have a negative x, right? In order to cancel out negative 5x, I gotta add a positive 5x to it. So in order for us to make this negative x become a positive 5x, what we're going to have to do is we're going to have to multiply it by a negative 5. So I'm multiplying all of this by a negative 5. So I'm going to rewrite everything. I'm going to rewrite number 1 again, which is negative 5x minus 3y plus z equals negative 4. That stays the same. But the third one, I multiplied it, right, by negative 5, because a negative 5 times a negative x equals a positive 5x, which that's what we need in order to cancel out x, okay? So negative 5 times negative x is a positive 5. Negative 5 times z is a negative 5z. And negative 5 times a positive 5 is a negative 25. Okay, so once again, a negative 5x and a positive 5x cancels out. So now all we do is we put the rest together, okay? So I'm just gonna bring down that negative 3y. Positive z minus 5z is a negative 4z. And a negative 4 plus a negative 25 is a negative 29. Okay, so this is the second new equation that we got, right? Remember, we labeled the first one as A, so we're going to label this one as B. Okay? Now, we did this because now we only have 2 variables. That's what we want, right? So we already eliminated X, right? We're going to use these 2 new equations to now eliminate either Y or Z, okay? and I'm looking at my notes, I chose that I want to eliminate z, okay? So step 3, use equations A and B to eliminate z. Or you could have chose to eliminate y, but in this particular case, I'm going to choose z. So we're going to eliminate z. Okay, that is step number 3. So once again, I'm going to rewrite those 2 new equations that we came out with. So the first one, which is A, once again, I'm always going to label in color code so it's easy for you to follow, is negative 2y minus z equals negative 6. Equation B that we came up with is a negative 3y, right, minus 4z equals a negative 29. Okay, real quick, just gonna color code everything so it's real easy for us to follow. Okay, so remember guys, we chose that we chose to eliminate z in this particular situation, right? I have a negative z and I have a negative 4z, right? The only way to eliminate negative 4z is if I added a positive 4z to it, right? So in order for us to make this negative z become a positive 4z, we have to multiply the top equation, which is A, by negative 4. Because a negative z times negative 4 is a positive 4z, okay? So we're just gonna rewrite that. So once again, I have a negative 4 times a negative 2y, which is a positive 8y. A negative z times a negative 4 is a positive 4z. Equals a negative 6 times a negative 4 is a positive 24. Okay? So let me color code. Okay? We didn't do anything to B, right? So B stays the same. So I'm just gonna bring B down as itself. It stays the same. So I still got a negative 3y minus 4z equals a negative 29. We're actually almost done. I know it's a long process, but we're almost done. So once again, guys, the variable that we chose was z to eliminate, and we can eliminate z because a positive 4z and a negative 4z cancels out. Okay, so everything else we just put together, okay? So 8y minus 3y is 5y equals 24 minus 29 is, no, 24 plus a negative 29 is a negative 5. Or 24 minus 29 is a negative 5. Same thing, right? Color code everything. So now we're down to the point to where we can actually find the value of y, right? So I'm going to divide both sides by the coefficient of 5. So I can get y by itself, okay? So negative 5 divided by a positive 5 is a negative 1. So in this whole system of equations, the value of y for all of these equations is negative 1. Okay? So we already found one of our values, which is y. Okay? So that is one of our answers. That's answer number 1, right? But we still have 2 more variables that we got to find the values of, right? Which is z and x, okay? Now, what I'm going to do is I'm going to take one of these smaller equations that we took, right? Since we know the value of y, we can plug in the value of y to figure out the value of z. So I'm going to use equation B, okay? So once again, now we're going to find the value of z. So once again, I got negative 3y minus 4z equals negative 29. And all we're going to do is, guys, we're just going to plug in the value of y, which is negative 1 as y, okay? So we're going to plug in as y, negative 1. Okay, so -1 times 3 is -1 times a -3 rather, is a positive 3. Okay, so now I have a positive 3 minus 4z equals -29, right? Now, once again, since z is the only variable, we can find the value of z, okay? So I'm just gonna subtract 3 on both sides to get -4z by itself on one side. -29 minus 3 is a -32. So I have -4z equals -32. And remember, we gotta get z by itself. So we divide both sides by -4. -32 divided by -4 is a positive 8. So the value of z is a positive 8. So this is answer number 2. Okay, lastly, guys, we gotta find the value of x, which was the first value that we eliminated, right? So what we're gonna do is we're gonna go back to one of our first equations, and then we're just gonna plug in the value of z and y to find out the value of x. Or really, you can use equation number 3 because you really only need the value of z to be plugged in to find out x, right? So let's go ahead and do that. I'm gonna use equation 3 because that's the more simpler one. So once again, the last thing we need to do is we need to find the value of x. That's the last and final thing. Once again, I picked equation number 3. That was a part of my system of equations, which is -x plus z equals 5. Once again, remember the value of z is 8, right? So all we're gonna do is we're just gonna plug in 8 as z. So z is 8. So now I have a -x plus 8 equals 5, right? To get -x by itself, I gotta move 8 to the other side. So I'm gonna subtract 8. All right, so now I have a -x equals 5 minus 8 is a -3. So if -x is -3, that means positive x equals positive 3. Or you could have divided both sides by -1, you would have got positive 3. So this is our final answer. Answer number 3, right? So once again, we found out the value of y, which is -1. We found out the value of x, which is positive 3. And we found out the value of z, which is a positive 8. Now, what we can do is, just to make sure, and we only need to do this with just one of the original equations. All we need to do is just plug in those values to see that it actually equals what it says it equals, right? So I'm just gonna pick number 1, okay? And once again, number 1, I'm gonna plug in the values of the variable. So I have a -5 times x. Remember, x is a positive 3. So I have -5 times a positive 3 minus 3 times y. Remember, y is -1. So that's -3 times -1 plus z. And remember, z is 8. And all of that has to equal -4. Okay, so we're gonna see if it equals -4. -5 times 3 is a -15, right? -3 times -1 is a positive 3, so that's plus 3. And then 8 is just 8, right? -15 plus 3 is a -12. And -12 plus 8 equals a -4. So this is how you know that we have the right values of this system of equations, okay? So once again, this is how we solve system of equations by the elimination process. I will come out with 2 more examples next week. I'll see you then.